Pictures are always helpful. Well, maybe not always, but very, very often, majority of cases, pictures are helpful in analyzing anything because we're a visually oriented organism. Now, here's an argument. If you work hard, you will pass. Joe works hard, therefore Joe will pass. Now, assuming that you means anybody, and maybe that assumption is implicit here, and then that argument, then this statement would apply to Joe as well as anybody. So, I guess we could translate this statement. Instead of saying, if you work hard, you will pass, we could say, all hard workers pass. Let's see how this applies to Joe. Let's draw a circle, one circle representing the set of all hard workers. Okay, and let's label that H for hard workers. And then we're going to have another set that represents everybody who passes. Now this says that all hard workers pass, which means that the set of all hard workers is a subset of the set of everybody who passes. We could even put this way: all hard workers pass means that the set of hard workers is a subset of the set of all who pass. And if we then draw a circle representing that situation where H is a subset of P, we see that we have this. Now, the key idea here is we want to confirm that Joe will pass. So the question is, where is Joe in this circle? Is Joe inside the passing circle, or isn't he? You might want to think about that before you watch the rest of the clip. You might want to pause at this point. But we said that Joe works hard, right? And we can't really see that. Joe works hard. Well, that means that Joe is in the set of hard workers, right? So that when we put Joe in here, we have no choice but to put him somewhere in the circle of hard workers. Now, if Joe is in the circle of hard workers, then certainly we're going to have to conclude that Joe passes. Okay, the conclusion is there's no way to put Joe in this picture except to put him inside the circle of passing. Conclusion: Joe must be in H, the set of hard workers. Okay. Now we go to the next argument, and we're going to analyze this argument. Okay. This argument says all mathematicians are absent-minded. Some linguists are mathematicians. Therefore, some mathematicians are linguists. Okay, maybe that sounds logical, and maybe it doesn't, but that doesn't necessarily have anything to do with whether it's true or not. So let's just see how this one works out. Okay, this says that all mathematicians are absent-minded. Now, we're going to translate this statement, all mathematicians are absent-minded, as saying that if it's a mathematician, then it's absent-minded. Well, that says that the set of mathematicians is a subset of the set of absent-minded people, where M is a set of mathematicians and A is a set of the absent-minded. Okay? The second says some linguists are mathematicians. Now, what's that telling us about linguists and mathematicians? Now, that really just tells us that the intersection of the set of linguists and the set of mathematicians is not empty. If we want to put this into set theory, that's the way it would be. Now, our conclusion is some mathematicians are linguists. So the conclusion would be that the set of mathematicians and linguists, the intersection, is not empty. And of course, that really just follows from this statement. Okay, this statement is really in a way equivalent to this statement. Okay, actually they're completely equivalent theoretically, because the intersection L intersection M is the same as the intersection M intersection L. Okay, nevertheless, we're going to use this to see what we can find out about the two sets. Here's a set of mathematicians, and here's a set of absent-minded people. Okay, this says all mathematicians are absent-minded. And it says some linguists are mathematicians. Okay, so if we draw the set of linguists, here, the set of linguists, the conclusion is that this part is not empty. Okay, we have to conclude that the set of linguists has a non-empty intersection with a set of mathematicians. Okay? Now the conclusion, therefore some mathematicians are linguists, note that that doesn't even involve the first condition, that mathematicians are all absent-minded. We could make all kinds of conclusions. We could certainly conclude that some linguists are absent-minded, since there are linguists who are mathematicians, and the set of mathematicians is a subset of the absent-minded people. But in this case, we don't need that. We simply see that since some linguists are mathematicians, some mathematicians are also linguists. And this is a picture of the situation. We don't know if there are any linguists who aren't mathematicians, although certainly we know there are, but that's not part of this argument. And we don't know that there are some mathematicians who aren't linguists. And we really don't know whether all linguists are absent-minded, so maybe this set of linguists has to come out here. Maybe there's some linguists who aren't absent-minded. If we want to draw this in all its generality, there's nothing to contraindicate that there are linguists who aren't absent-minded, so maybe that set has to extend outside the set of absent-minded people to some extent.